Hello, my name is Naoki Ichijo from Waseda University, Tokyo, Japan. Today, I will talk about our work entitled Meta-tree Bayesian Approach to Avoid Overfitting in Decision Trees and Analysis on the Application to Boosting, which will be presented in IEEE International Workshop on Machine Learning for Signal Processing 2025. In this research, we focus on regression problems using decision trees. Given explanatory variables x and responses y, the task is to predict an unknown target for a new input. The mainstream approach in machine learning is the predictive function approach. Fit the function to the training data and then use it for prediction. However, this approach is mostly heuristic and lacks discussion on predictive optimality. In practice, decision trees suffer from overfitting, and the major approach to avoid overfitting is pruning. However, pruning criteria are heuristic and often determined empirically. In this research, we employ the Bayesian decision theoretic framework. Instead of selecting one best model, we consider a predictive distribution obtained by posterior weighting over multiple tree structures. In other words, the Bayesian approach weights tree structures probabilistically. And this is different from pruning or frequentist model selection, shown in left side figure. It is a Bayesian approach that avoids overfitting in a principled way. To realize this, we employ the concept of a meta-tree, which was presented by Tobashi et al. A meta-tree is defined by the maximal tree structure, node splitting probabilities, node level parameters at leaf nodes, and splitting laws. Posterior updates can be calculated recursively with computational complexity proportional to the number of nodes. Also, predictions can be calculated recursively as well, with computational complexity proportional to maximal tree depth. In this research, we convert a conventional cart tree into a meta-tree and propose this process as meta-treeization. We integrate meta-trees into the gradient boosting framework. We call this method gradient boosting meta-tree. The procedure is as follows. First is to construct a decision tree by cut on the residual vector. Second is meta-treeization. Fix the tree structure and splitting laws, and then update posteriors. Third is to predict the residuals using the meta-tree. And finally, fourth, update the residual vector, and we repeat these steps. This allows boosting to benefit from Bayesian model weighting by meta-tree at each step. We compared meta-trees with standard carts, both with and without pruning. For single trees, meta-tree achieve lower test error and show less overfitting, which is shown in left figure. In ensemble experiments across UCI regression datasets, GBMT outperforms conventional gradient boosting, especially when the maximal tree depth is large. For example, GBDT with depth 15 severely overfits, while GBMT remains stable with much smaller performance degradation. To summarize, we introduced Bayesian approach to decision trees through meta-trees, which is presented by Tobashi et al. This method naturally avoids overfitting by posterior model weighting. We applied it to gradient boosting framework and demonstrated improved performance and stability in synthetic and benchmark dataset, both individually and in an ensemble. Thank you very much for your attention.